start. We are in week 11, and today we'll be talking about custom views. So I will show you how you can create a view that is, well, custom made depending on your needs, right? I will create a single view application. I don't need more than that. Lab 11. Okay, here we are. Okay. What I will need? What I will build. Let's start there, right? I will create a view that will be representing a card. Right, as simple as that. A playing card with the information about suit and rank displayed in two opposite corners. Okay, so the regular card, you can extend that later on with the images and stuff like that. So what I will need for sure a class that will represent my card. All right, so I will create a Swift file that I will call a card. And that will be a class. Let me change the font size before we start coding. I will have a class card. I'll have a rank. Rank will be an integer, and I will have a suit, and it will be a string. Right. And we'll create an init rank int string. Right, and what are we? Okay, init rank int and we need to set the values, right? So self rank is equal rank, self suit is equal suit. That's it right now, right? For the class. What we'll do, we'll be working with two things. We'll be working with a custom class, custom implementation, and we'll be working with a storyboard. So right now I will open the storyboard and I will add a view. View that is represented somewhere here. This one. A simple white rectangle. If you take a look at the identity inspector, the class that is behind that that rectangle is UI view. And to make it custom, right, we have to provide the implementation. So we'll have to provide a new class. In this case, I'm selecting Coco Touch. The class that will inherit from UI view, and we'll call it card view. Okay, next, and create. So this is my implementation. We'll get back to it. Before we do anything, we'll get to the storyboard. We'll make sure that this view that we added to the storyboard is associated with ours, right? With our class, card view. Okay. Now we can start doing the implementation. And in implementation, we have to think about two functions that are quite important for the view. One of them is in this comment, and it's called draw. This is function that is responsible actually for drawing the view, right? You can do all kinds of stuff here. I'm sorry. You can do the you can change the color. You can draw custom shapes and so on. You can also create views inside the one that you create. So draw is one function. Second function that we'll be looking at is actually a function called that is responsible for laying out the subviews, right? And because we'll create something that is a complex view, we'll need that, right? Because we'll add labels to our view that we create, right? I'll just pull out my notes from my computer and we'll continue. So what we'll need here, definitely for the card, we'll need the information about what card it is, right? So we'll have a variable here. And I will just a second, I will continue with that. We'll have also two other variables that will be representing our labels, right? So we'll have top label, and we'll have bottom label. Both of them with a question mark, so we don't have to set them right now. We'll create the init function in a second as well. Okay, labels. Now, to create those views, we'll need init. We'll override init from the parent view, from the UI view. First thing that we'll do, we'll need to call init function from the parent, and then we'll call function that we'll add in a second that will be called setup view. This function will create the labels and will position them in a proper place. This class, I mean the parent class UI view, also has another init function that is required. Required init, and we'll do the same thing, right? So we'll call super init with the encoder, and then we'll call the setup view function. So let's add this function. Setup view. Let's do a simple thing right now. So this will be a private function. Let's do a simple thing, and let's let's simply set the background color for our view. Background color, red. Simple thing. What are they? Oh, card is not set. I will make them all optional right now, so it does not complain about those cards not being set. Okay. I run my code right now. What we should have is a red rectangle. Ta-da! Let me show you one thing. If you add here to the class, here right before the class, if you add annotation at IB designable, and let's say we'll declare a color var color UI color, say red in the beginning, and you add IB inspectable. Inspectable. What you will see in the storyboard is that you can modify the color here. See the card view and the color. And you can modify the color. Let's say we'll set this color. Right now, it's not updating it because we don't have a functionality for that. But if we run this, did I change it? Sorry, did I change it in the code? I think I didn't. Yeah. And if we do it this way, this color should be used, but it's not. This code should be used and it should be updated later on. What was the color that we selected? Okay. Current view. Making sure that it's the right one. Okay, I'll have to find out why it's not reading this color. Anyways, what we have to do, we have to create the labels, right? And what I will do, I will define a function, another private function, that will create a label. We'll return UI label. Right, so we'll have a label. And we'll returning at the end. In the meantime, we have to decide how the label will look like. Right. So first, it's a playing card, so we'll display the rank and suit in two different lines. Right. So number of lines will be equal to. And then we'll add this label as a subview to our current view. And then we need to set a text. Right now, I will use a text, so regular text. Card rank. And card suit. All right, so that's the text. That's the text that I want to show. And I will call this to create my first label, right? Create label. Can I do that? No, I cannot, right? It's telling me cannot use instance member create label within property initializer, right? what I can do with this. I can either call this function in init, or I can make my property lazy. If I make it lazy, means that it will wait till anybody asks for this, right? Specifically, it will wait till the object is initialized, right? Because this is object level variable, right? You cannot access it from the class level, so it will have to wait, right? So I have my label added. Let's see. What's the problem? We don't know what is the size of our label. That's why we cannot see it. What I can do, I can say that the frame size should be equal to CG size dot 0. I mean, I'm resetting the size, and then I can set say lab size to fit. Now this will work only if we know the font size and everything else for the font that we are using. So instead of the text, instead of this one, what I will do, I will create a function that will allow me to create attributed text. Attributed text will give me more options in terms of my view. All right, so let's create a function. Attributed text. This function will take few parameters. First one, it will be a text that we want to display. The second one will be font size, e.g. float. And this function will return at the end ns attributed string. What we'll have to do, we'll have to create a font. That's UI font. We'll take a font from the system, preferred font. That is used in the body. And we'll say that this font will be with the size that we are given, right? So font size. We have a font ready. We'll have to create paragraph style. Let paragraph style to be equal to ns mutable paragraph style. And we'll change one thing, the alignment. We want the text to be centered. And now we can return ns attributed string. We have the string ready. And for attributes, we'll say that the paragraph style is our paragraph style, and that the font is font. And now I can change this to attributed text. And in this one, I can say that I want my text, right? I want my attributed text. This is a string that I will put there. And now I have to create or use the font size. Let's say it will be 20 for now. I'm hard coding this value. What's the problem? We don't have the card, right? Card. Where is our label? Oh, I never called the function. Or I did. Oh, create label, okay. So we should be there. But we are not. And why? Oh, sure. We are not calling this function because it's lazy, right? Let's add function that will lay out the views. So let's add layout subviews. This function will position the our label. So the top label origin, frame origin, will be set to the parent view, to the bounds dot origin dot. And now it would be nice to have a function that will offset our point. I would like to do this. Offset by, and then say dx equals to 10 and dy that is another 10. I don't have this function in my in the library. So what I will do, I will add extension to the CG point. Extension CG point And I will add function that I'm missing. Func offset by dx tg float and dy tg float. And this function will return another CG point. Return CG point x plus dx and y plus dy. Okay? So this is my extension. It allows me to operate on the CG point in a little bit easier way, right? I don't have to create a new point and read it from the current one and so on. I simply call the function. What this should do, this should really trigger everything else. Right? I'm here. Ugly, optional 1, optional x. Let's unwrap it to have a proper thing, right? What's the problem? Same thing. I have my label here. I want to do the same thing with the bottom label. Again, I will create a label. So this one has to be lazy. And I want to create the bottom label in a way that it will be, of course, on the bottom, but also upside down, like on the playing cards. So I have to do a few things. First, I have to move it, and I have to rotate it, right? Let's start from rotation. Bottom label. Each field has a transform property, and transform property allows you to do all kinds of stuff, like moving, rotating, and so on. e.g., affinity transform is the type that is stored there, and we have a basic transformation that is called identity, and that's the current value of this field. Identity means do nothing. But from this, we can use things like rotate it. We know that we want to rotate by 180 degrees, which is in radians is pi, right? CG float dot pi is the value. Also, we need to move our field, right? Our label, and we'll use we'll use our offset by function to do that, right? So we'll say bottom label dot frame dot origin is equal to, hide this so we have more space, is equal to bounds dot origin dot offset by. Let's do it in few steps. So first, let's move our label down to the corner of the view, right? So it will be bounds dot max x and bounds dot max y. If we'll leave it like that, our label will be over here. But we want it to be 10 pixels from the border the same way that the top one is. So let's move it farther. Offset by right, 10, 10. If we do this, it will move it, but just a little bit. It's closer, but not exactly where we want it. So before, offset by bottom label bounds max x and max y. Now it is in the position where we want it to have. We can simplify that, right? Doing our math and doing it in one operation. But you see the steps here, right? Why this is in a position that it is. Okay, now whenever the value of the card will change, what we want to do, we want to refresh what we are showing, right? So we want to create a trigger bit set, and in this trigger, we want to notify the system that it should refresh and it should reposition the values, right? So set needs display and set needs layout. Set need display is calling the draw function. Set needs layout is calling the layout children, right? Or layout subviews function. Let me do it. I cannot do that with class. So let's modify our code. Instead of using card, let's use just suit and rank. Right, so we'll have rank that is int and is equal 1, and we'll have own bit set and we'll have suit for which we'll do exactly the same thing. Okay? Suit string first I will have to modify my code here, get rid of this. So we have the same result, right? In the main storyboard, we can see our card. And you can see that we can also modify the rank and the suit. What else you can do? You can draw things in the draw function. Right now, our draw function is quite empty. The only thing that we do is setting up the background color. But you can do other things. You can, for example, draw something, a Bezier path, right? So let's say I will draw a rounded rectangle. UI Bezier path. Rounded rectangle. Will be of the same size in terms of bounds. The bounds will be of the same size as our field. The corners wrong version. There is another version of this one. I wanted this one. So bounds is the size, and the second parameter is just the radius of the corners. Right, and we can set that in an arbitrary way, or we can let the user to control that. Again, depending on what we want. Right, if I do this, I can now draw the path. Right, I have path defined. The next thing that I have to do, I have to add it. So here, rectangle at clip. I can set the background color, UI color let's say gray set fill. I can draw it with this color. And that's it. I should see the rectangle right now. And you see that it has those rounded corners, right? And if we go to the storyboard, you can also see that this is our rectangle. What else I can do? I can make this radius a variable, right? And I can make it inspectable at IB inspectable var radius tg float. You can see that we can make it very round or just a little round. Right, so that's my card. Now, cards can be flipped, right? So what I will do to my card view, I'll add another parameter, var is flipped or is face up. Is face up, full equals true for the beginning. And what I will do, I will show those labels only if they are if the card is facing up, right? So top label is hidden equal not is face up, and the bottom label dot is hidden equal no is face up. So it is. Same thing here. And I can modify it here, right? On meaning face up, off face down. And if we run it like that, our card is facing down. Let's add functionality to this card so it can be flipped. Okay? How we can do that? We'll do it with the gesture recognizers. And we'll use a swipe gesture recognizer to generate a new card. And we'll use a tap gesture recognizer. So we'll use tap gesture recognizer to flip the card. Okay. Now the gesture recognizer is set on the parent view. So we are going to view controller. In this view controller, what we'll do, we'll create an outlet. Let's hide this. We'll create an outlet to our card. And for this outlet, here, I will also create I'll also create a listener. Did set. Did set, then I will create a gesture recognizer. Swipe. UI swipe gesture recognizer. This recognizer will take two parameters. The first one is a target, and that's easy, that's self. The second one is action. What will be the action? The action will be a function. Let's create this function right now. Function called next card. All right. This function will have also an annotation. Add Objective-C. This annotation allows me to use it in the context where Objective-C function is needed. And in here, I will say hash selector, and in the as a parameter to this, I will say next card. The next thing that I will do is the configuration of my swipe. Swipe.direction can be down, left, right, or up, or it can be any combination of it in the array. I will use left and right. Now card dot add gesture recognizer. Swipe will add the gesture recognizer to my card. Now in the next card, what I will do, I will say card dot value. Sorry, not value, but rank is equal to card dot rank plus 1 in modulo 10. I'll have 10 values that I allow. So let's make sure that our card is up. Let me see the code. This should work. So the gesture is recognized. Rank. It should execute this function here. And it does. Then we should go to the layout. What did I forget? Oh, this one. Right, the attributed string is set in create but never refreshed. Right, so we should redo that in here. Right, we should repeat this for top label and the bottom label. And it should work. All right, you can see that it's changing the value. So that's one way of adding the gesture recognizer to your application. Another way, and it's programmatic, right? So you can do it at any point. Another way is simply dragging the gesture recognizer from here to your card. All right? So I'm adding it. What happened here, let me show you here, you have a new icon. And now what you can do, you can start the sorry, you can go into the assistant view, right? And we can create a function the same way that we do. Oh, come on. Right, click and drag, right? The same way that we create actions for our fields, right? So action, UI tab gesture recognizer. My action will be called tab action. Connect. Now, if you click on that and you take a look at the inspector, you can configure your gesture recognizer, right? this configuration will change depending on the type of the recognizer that you use. In this case, we have number of taps and number of touches, right? You can configure a tap that has to be done 3 times with 4 fingers, right? And other things like that. For the emulator, I will leave it with 1 finger and maybe two taps, right, to flip the card. You can enable and disable the recognizer. You can cancel touches. You can delay things. You can do many other things this way. Let's go to our function. When it's recognized, what I will do, I will simply say card dot is face up equals not card dot is face up. And that would be everything, but I may have a situation when the gesture is not fully recognized. You know, you have the situation when you have a tap, but you have also a swipe, right? So when you're reacting to a single tap, it may not be exactly the tap, it might be a beginning of the swipe. So the sender has a state, right? And we can say switch sender dot state, and we can say what happened. It's ended. It means that we recognize the gesture. Nothing else can be recognized from that. But there are also other other options. We use only this one, right? So I'm taking this code and placing it here. If it's default, so anything else will break. What was the setting? Let's take a look at the settings. 1 tap. Okay, here we are. Oh, I know what I didn't do. Let me do it right now. I didn't set the listener in the card view. I didn't set the listener or on this field, right? I should do the same thing that I did for other fields. So it resets the view, right? When I tap. Right? Showing up on and off. And with the swipe, we can modify it. Hey, what else we can do? We can make this view to work with auto align, right? So we can go to the storyboard and we can add some constraints. Sorry, we can add some constraints to this view. So let's say we want to center it horizontally. We want to center it vertically. What else? We want to fix the aspect ratio. And we'll have all those views here. And maybe we'll add, we said that the aspect ratio will be fixed, and we want to fix also the width. Okay, add 2 constraints. So it looks like that. If I play it, it's going to the center. Now, what I want to do, I want to make it big. So I will edit the width. And I will set something crazy. It goes red. It goes red because with this setting, it's impossible to stick to other elements, right? It's impossible to fix it within given space. What I can do, I can change the priority of this one. I can set it to high. And then there will be a little bit of magic. But not with this one. I have to remove one of them. Now we'll have a little bit of magic. We have our card stretched. And we can set 5 to 8, for example. This is aligned, this is aligned. Let's change it to something smaller for now. We are back. Let's add one more thing. Let's add a space before the margin. Let's add needing two. Let's fix it like that. Positioning the view. This one. Okay, we are back. We can play with those. See, it's not going outside of the scope, right? Because right now, the margin that we have plus the aspect ratio, those 2 constraints are keeping it inside the screen. And at the same time, they're pushing it far enough, right, to somehow use all the space that we have available. If we turn our device, it should rotate. keeping the aspect ratio, but it didn't. I think I lost one of the constraints. Line in safe area, X and Y, leading space, aspect ratio. Let's use preview. Preview doesn't show it correctly. I will have to check which constraint is missing. Right now, I don't think I will find it. Because it should, maybe the top. Let's try this one. Yay! Okay, so now it's holding right the position to the top and to the left, and we can rotate, and it stays more or less within the bounds of the screen, right? That's what we wanted to have. Okay. So what you know? You know how to create a custom view. You know that you can add programmatically new elements to the view, right? This is label, but you can use UI image, and you can have more complex stuff. You can work with that either here in the either as in programming, or you can work with this view in the view inspector, right? Setting up some parameters here, right? So this is your custom view. I will stop the recording right now.